Welcome to the next lecture on the course Descriptive Statistics with R software. Now you may recall that up to now what we have done? We have considered two aspects of data. One is the central tendency of the data, another is variation in data. And both these aspects, they are very important part of the information which is contained inside the data. Now I am coming to another aspect. Suppose we have data set and we want to know the variation in the data set, that should also depend on the measure of central tendency. What does this mean? Up to now, we have taken the aspects of central tendency and measure of variation separately, one by one. Now I would like to have a measure which can inform me the information contained inside the data based on arithmetic mean and variance. This will help us in getting an idea about the variability in the data in various type of situations, where using either the mean or the variance may not really be advisable and may not really give us the correct information. So in this lecture, we are going to first discuss about a tool or statistical tool to measure the variation. This is called as coefficient of variation. And after this, I will try to consider one quantitative measure and say another graphical measure based on the R software to have a combined information on various aspects. So let us start our discussion with the coefficient of variation. The coefficient of variation measures the variability of a data set without reference to the scale or units of the data. What does this mean? Suppose I have got two different data sets. One is measured in say centimeters and say another is measured in say meters. In case if you simply try to combine the mean and variances of the two data set and if you try to compare that, it might be little bit difficult. Similarly, in case if you want to compare the house rents say in India and say house rent in US. The house rents in India, they are given in Indian rupees and they are with respect to the salaries that we get here. Similarly, if you go to US, the house rents are going to be in terms of US dollars and they are also with respect to the salary structure in US, and the salary structures in US and India, they are very different. So sometimes you have heard that people simply try to multiply the dollar by the exchange rate and they try to say that okay, I am earning this much or I am spending this much or I am paying this much of house rent. So how to handle these types of situation? That can be done using the concept of coefficient of variation, right. So this coefficient of variation will be useful to us when we try to compare the result from two different surveys or they are obtained from two different tests and they are obtained on different scales. For example, if I say that I have got here two data set and we try to find out the arithmetic mean and standard errors of the two data sets. So the sample mean of the first data set is obtained here as say x1, first data set's mean, and x bar 2 is the arithmetic mean of second data set. And similarly, I try to find out the standard errors S1 and S2. So, standard error S1 correspond to the first data set and standard error S2 correspond to the second data set. Now, there are two aspects, mean and standard errors, or say central tendency or variation. Now, how to compare the two data sets? That is the question that we are going to entertain here. Now, the definition of coefficient of variation. As we had discussed in the earlier lecture in case of variance, that the variance can be for the entire population, which is usually unknown, or the variance can be for the sample, that is called as sample variance, which is computed. Similarly, in the case of coefficient of variation, we have two versions, one for the population and one for the sample. But here, when we are trying to discuss the tools of descriptive statistics, we want to compute everything on the basis of given sample of data. So, I am going to discuss here the sample version of the coefficient of variation. Please keep this thing in mind. Okay. So, once I have got the data, say x1, x2, xn, this can be either for the group data or say ungrouped data, or whatever you want. Then the coefficient of variation is defined as standard deviation upon mean. So, if you remember that we had denoted the variance, sample variance by SA square. So, the standard deviation, or in simple language we call it standard error, whatever you want to call, I am trying to consider both as a similar meaning without any loss of generality. This is denoted by say here S, and sample mean we already have denoted by x bar. So, this coefficient of variation briefly denoted as CV, this is defined as S upon x bar. Now, if you try to see, standard deviation will always be positive. So, this coefficient of variation is properly defined only when the mean is positive or x bar is greater than 0. See here, this definition of CV, this is based on the sample. Now, if you want to understand what is the population counterpart, then if I say that sigma square is the population variance and mu is the population mean, then CV of this population will be defined here as a sigma upon mu. But since we do not know the value of sigma or mu, so we try to replace it by S for sigma and x bar for mu. So, this gives us the sample based definition of the coefficient of variation, which can be computed using the data x1, x2, xn. Right. Now, the next question is how to take the decision, because coefficient of variation is also a measure of the variation in the data. So, if I have two data sets, then how we are going to measure it. And now you can see here that if I try to take here two data sets in which suppose the arithmetic mean of one data set is greater than the arithmetic mean of data set 2, and suppose the standard deviation of first data set is smaller than the standard deviation of data set 2. So, what is happening in one data set, mean is larger, but standard deviation is less, and in other data set just opposite is happening. In that case, which of the data you have to choose? That cannot be answered directly by using the mean or standard deviation. So, in these situations, the coefficient of variation helps us, and we say simply try to find out the coefficient of variation of both the data sets, and the higher value of coefficient of variation is going to indicate that the variability is higher. So, the data with higher CV is said to be more variable than the other. So, that is again similar to the interpretation of variance. Higher the value of variance, that means more variability, higher the value of CV, that means there is more variability. Just to explain you in more detail, let me take here a simple example where two experimenters have collected the data on the heights of same group of children. One experimenter has taken the observations in meters and other experimenter has taken the observations in centimeters, and they have found the average height and standard deviation of the two data sets. So, you can see here I have tabulated the information. This is the first experimenter, second experimenter, and first experimenter has found the average height to be 1.50 meters and standard deviation to be 0.3 meters. And similarly, the second experimenter, he has found the average height to be 150 centimeters and the standard deviation to be 30 centimeters. Now, this is the usual tendency to compare the standard deviations. So, you can see here the value of standard deviation is 30, whereas here this value is here 0.3 in the first case. So, obviously, in the first look it appears that 30 is much greater than 0.3, and this indicates that the variability in the second data set is very high, but this conclusion is actually wrong, because if you try to see both sets of measurements, they have been taken on different scales, but they have got the same value. The heights, say x1 bar and say here x bar 2, they have the value 1.50 meters and 150 centimeter, which are the same. And similarly standard deviation, they are 0.3 meters and 30 centimeters, they are also the same. So, now in this case, how to report it or how to identify it, how to know it, that is the question. So, in this case, this coefficient of variation comes to our help and rescue. So, if I try to find out the value of coefficient of variation in both the cases, then in the first case the coefficient of variation comes out to be standard deviation divided by mean, which is 0.3 divided by 1.5, and this comes out to be say here 0.2. And in the second case also, the coefficient of variation comes out to be 30 upon 150, which is equal to 0.2. So, you can see here that both the values are same, and this is indicating that both data sets have the same variability. And this was not possible by looking only at the values of mean and standard deviation. So, similarly, this coefficient of variation also helps us in comparing the data sets on two completely different measurements. These observations can be obtained on different scales, but the advantage what coefficient of variation has, that coefficient of variation is dimensionless. So, this helps us in the comparison of the variation in two data sets. For example, India, if I take an example of rents of houses in a metro city and in a village, we know that the rents in a metro city in India, they are very high, whereas the rents in a village that are also very low. And similarly, if I try to take say another example, the rents of houses in Mumbai, they will be in Indian rupees, and the rent of houses in London, that will be in pounds. Now, how to compare when the data has been obtained in the same unit as in the first case when we are trying to find out the rents in India in a metro city and a village, and when the data has been obtained in different units, that is as in the case of rents of houses in Mumbai and London. So, how to compare? Then again in this case this coefficient of variation helps us. Now, the question is how to use this concept of coefficient of variation in making a decision. So, the data set having higher value of coefficient of variation is thought to have more variability. So, definitely when we have lower value of coefficient of variation, this is preferable. For example, in case if I have two data sets and suppose we have computed their coefficients of variation as CV1 and CV2, then if CV1 is greater than CV2, then we consider or we say that the data in CV1 has more variability or say less concentration around the mean value than the data in CV2 or in the second data sets. And similarly, in case if I have the opposite, that CV1 is smaller than CV2, that means the data in CV1 has a smaller variability than the data in CV2. Right. Now, the next aspect is how to compute it on the R software. So, as such there is no built-in command inside the R software to compute the coefficient of variation, but computing the coefficient of variation is very simple and straightforward. This is only the function of standard deviation and arithmetic mean, and we already have learnt how to compute the standard deviation and how to compute the arithmetic mean. So, just by using the same commands, we can always compute the coefficient of variation. So, this is how we are going to compute the coefficient of variation. Okay. So, if I say that we have got a data vector x, then the coefficient of variation is going to be defined as like this. What is this? Coefficient of variation is simply here standard deviation upon mean. So, standard deviation was nothing but the square root of variance, and mean was by the function here mean of x. So, this is what I am trying to do. First I am trying to find out the square root of the variance, that will give me standard deviation divided by mean of x, and this will give me the value of coefficient of variation. Now, if I ask you that how would you compute the coefficient of variation in case the data is missing, then it is very simple. How? We already have learned how to compute the standard deviation when the data is missing, and we also have learned how to compute the arithmetic mean when the data is missing. So, you simply have to use the same syntaxes, same functions, and you have to write down the syntax for computing the coefficient of variation. So, if you recall that what we had done earlier, suppose my data vector x has got some missing values which are denoted by NA, and I am denoting this data vector as XNA. So, now I will try to find out the variance of this XNA by using the command inside the argument na.rm is equal to true. So, this will help us in finding out the variance when the data vector has missing values, and then we try to find out the square root which will give me the standard deviation. So, this function will give me the standard deviation in the presence of missing data, and similarly the mean function on the data vector xna with the argument na.rm is equal to true will give me the value of the mean when the data is missing, and by using this command we can always find out the value of the coefficient of variation. And now, using the same command you can also write down the syntax and command for computing the coefficient of variation in case of group data. That is not so difficult, right. Now, I will try to take a small example to show you that how to measure it. Suppose I have collected the data on 20 participants in the time taken in a race, and this data has been recorded inside a variable time. So, this is the same example that I have used earlier. Now, in case if I want to find out the coefficient of variation of time, so CV of time, that is simply here standard deviation of time divided by mean of time. So, I am using here this syntax, and this is giving me this value is 0.3 and so on. And suppose if the data is missing, then in that case I have the same data in which I have replaced first two values by NA, and this data has been stored inside a new data vector time.na, and I try to use the same command to compute the standard deviation in the presence of missing value, and the command for mean in the presence of missing values, and I try to take their ratio, and this will give me the coefficient of variation, and this value comes out to be here 0.27. And you can see here, this is the screenshot of the same thing what I have done. Now, I will try to show you on the R console also. I am trying to take the command, and this data has already been copied, which is the same data set here time, and if I try to find out the coefficient of variation, this is giving me this thing, right. And similarly, in case if you want to find out in the presence of missing values, then I already have stored the data time.na. You can see here, and if I try to use the same command on this data set, you will get here the same value, and the same value has been reported here in this slide. This is the screenshot. Now, I have completed different types of measures of variation that we had aimed. Now, I am trying to address another aspect. When we get the data, then data has all sorts of feature, and we would like to have all sorts of feature like measure of central tendency, partitioning values, variation, and so on. Up to now, what we have done, we have taken all these aspects one by one, means how to compute maximum among the data values, minimum, range, quartiles, and so on. In R software, there is a command by which you can compute all these values like as minimum value, maximum value, and different types of quartiles in the single shot. So, I am trying to discuss now this command, which is a summary command. So, in R, there is a command summary, SUMMARY, and this summary commands provides us a comprehensive information on different types of quartiles, mean, minimum, and maximum values of the data set. So, if my data vector is denoted by x, then we use the command SUMMARY summary, and inside the arguments here x. And if you try to use this, then the outcome of this command will give us an information on the minimum values, minimum value, maximum value, arithmetic mean, first quartile, second quartile, this is median, and the third quartile of the data set which is contained inside the data vector x. Now, let us try to take an example to understand it. And now, I take the same example that I took earlier, where we have the data on 20 participants in the time taken in a race, and the data has been stored in a variable here time. So, now when I say summary time, then on the execution we get here an outcome like this one. So, you can see here there are 6 values, first value here, second value here, third value here, fourth value, fifth and sixth. So, now if you try to understand what are they trying to give us, the first value here is giving us the minimum value, minimum of the values contained in the time data vector, which is 32, and you can see here this is here the 32. Similarly, the second value is giving us the value of the first quartile. Remember, this is quartile, not the quantile, right. So, you know how to compute the first, second or third quartile. So, but here in this case you need not to compute it separately, but it will give you inside the same outcome. Similarly, the third one is the median value, which is the second quartile. Third value is here the mean, that is the arithmetic mean. Similarly, fourth value is the value of the third quartile, and the fourth and the last one, the sixth one is the maximum value of these observations, which is here 84. You can see here this is the value. So, by using this summary command you can get all this information in a very comprehensive way, and that is the advantage here. And here you can see here, this is here the screenshot. I will try to show you on the R console also. So, if you try to come here, so if you see here that data on time here is already stored there, and if I try to write down here summary of here time, we get here this value. Okay, let us now come back to our slides and we try to discuss now another aspect. So, now you can see that this summary command is trying to give you different type of information, minimum, maximum, quartiles, means in a comprehensive way. And when we started the discussion on descriptive statistics, I had told you that there are two types of tools. One are quantitative tools and other are graphical tools. So, now the next aspect is this: whatever the information has been provided by the summary command, can it be represented in a graphical way? Now, now what will be the advantage of this thing? Suppose if you have two data sets or even more than two data sets, and if you want to compare all the characteristics at the same time, you can use the summary command on all the data vectors, and also you can create the graphics. So, graphics will give you a visual comparison of the information contained inside the different data sets. And in order to do so, there is a graphic which is called as box plot. So, now I try to discuss what is a box plot and how to construct it inside the R software. Okay. So, this box plot is actually a graph which summarizes the distribution of the variable by using different types of information like as median, quartiles, minimum, maximum. Remember, this will not give you the value of the mean. So, this box plot looks like actually this. You can see here a graph. You can see here there are two lines here, one in the bottom. Please try to observe the pen, one in the bottom and now other in the top in say green color. You can see here these two values are giving the minimum value of the data set and the upper value is giving the maximum value of the data set. Now, in case if you try to find out the difference between the minimum and maximum value, what you will get? You will get here the value of range. And similarly, if you try to look on these three lines which I am indicating here, first, second and third. So, if you try to see, this is here a sort of here a box, and the lower edge of the box which is here, that is giving you the information on first quartile. Now, I will be changing the color of the pen, so you can see it clearly. Similarly, the upper edge which is here, this is giving us the information on third quartile. So, if you try to see, if you try to find out the difference between the two, do not you think that this will give you an idea of the quartile deviation, and also in some sense it will give you the information on interquartile range. These two measures we had discussed as the measure of variation. Now, finally, if you try to look in the line in the middle of the box, this line is going to give you information on the median, which is the second quartile Q2. So, you can see that inside this box there are several measures which are combined, and just by looking at this difference and this difference, you can also compare the variation By looking at the middle value, you can compare the median and so on. So, let us try to first see the applications through the software. Inside the R software, there is a command here Boxplot, and inside the arguments you have to give the data vector for which you want to create a box plot. And there are several arguments which are several options available in the plotting of box plot. I would request you to go to the help menu and try to see what are the different arguments and what are their uses in creating the box plots. You can make the legends, names, colors, etc., shapes, etc. So, let me take here the same example which I considered earlier. So, this is the same data set on time, and now I have created here the box plot on this here time. So, you can see here this upper value, this is going to give me the maximum value of this time, and which is here 84. You can see here this is somewhere here. And similarly, the bottom line, this is going to give me the minimum value of this data set, which is here 32, somewhere here. You can see here this is the data set. Now, these three values, bottom value, second value and third value, these are trying to give me the information on first quartile, middle in the second quartile and upper edge in the third quartile. So, you can see here these values are somewhere here. So, you can compare it with the values that you have just obtained in the summary command. And by looking at the difference of these two edges here and these two edges here, you can have the idea on the variation in the data in terms of range and quartile deviation, or say interquartile range. Now, you can see here why this plot is called as box plot. You can see here that all the information is contained inside this box. So, that was possibly the reason that it was called as box plot. Now, what is the use of this box plot? How it is going to help us? So, now what I have done here, first you please try to notice what are the first two values which I am indicating here. These are 32 and 35. Now, what I do in the same data set, I try to make it 320 and 350, very high value, and I give this data a new name time 1, and then I try to create the box plot of the time 1. You can see here that this box plot is very different than what you have obtained in the earlier case. Not only this, it is also showing you that there are two observations which are possibly the extreme observation. So, by looking at this graph, this is giving you information. Well, when you are trying to analyze that data, please try to take a look at the values which are somewhere between 300 and 350. These values are unusual because they are very far away from the remaining data. All our data is lying between 50 and 100 here, whereas these two values are lying between 300 and 350. But my objective was that I want to compare it. So, I try to artificially make these two plots side by side. So, I have simply copied and pasted these two graphs manually, and you can see here that the first graph is for the data set time and the second graph is for the data set time 1. But now you can see still we are not very comfortable. Why? Because the range on the y axis in the both data sets, they are different. So, they are not really comparable. Well, they are comparable, but you need to put a hard work in the comparison. So, we would like to make a graph in such a way where we have only this type of boundary on say x and y axis, and this plot should be inside the same boundary, so that they are comparable. So, in order to do so, what we have to do? This I am going to now discuss. To demonstrate, we have a graphic which is called as grouped box plot. This graphic will combine different types of data sets and it will create a box plots inside the format of a box plot using the data inside the format what is called as data frame. What is this data frame and why this is needed? Suppose we have here 3 data vectors which I am indicating by x, y and z. So, what we want here is the following, that we want here a graphic which is enclosed inside this rectangle where there are 3 box plots like this, and they are indicating the box plots for the 3 data vectors x, y, z. So, in order to create this combined box plot, first we need to combine the data, and in order to combine the data we have a concept of data frame, and we do as follows, that we use the command here data dot frame, and inside the arguments we try to give the names of the data vector which are separated by commas, and this will give us a data set in the framework of the concept of data frame, and this data will be a combined data set. Now, at this stage a question crops up that what is a data frame? Well, data frame is a method to combine different types of data sets in R. Well, it is not really possible for me to explain this concept in detail here, but these concepts have been explained in the lectures on the course Introduction to R Software. If you wish, you can have a look on those lectures, or you can look into the help menus of the R software to have an idea about the concept of data frame. Right, but in this lecture I will be using only this command just to combine the data set. So, I am not going into that detail. I have given you the command that how to use it. If you want some advanced feature, advanced knowledge about this concept, I would request you to look into the books and help menus. Okay. So, now my objective is very simple. I would try to create a box plot for this data set which has been combined using the concept of data frame. So, now what I do here is the following. I try to take the same data set time and here time 1, and I try to combine it and create a data frame using the command data dot frame, and inside the argument time separated by comma and then time 1, and I store this data as a data box plot. And after this I use the command box plot and give the data inside the argument as data box plot which has been obtained through data frame. Now, you can see here that both the graphics have been combined together. Right, this is the box plot for the time and this is the box plot for the time 1, and here you can see that that is indicating the presence of 2 extreme observations. Right. So, in this case you can see that we have combined the 2 box plots, but they are not really informative because the ranges of both the box plots are very different. Right, this is here and this is indicating that there are 2 extreme observations. So, this is giving a different box plot that what we wanted. So, the ideal thing is that after looking at this picture, first try to remove the extreme observations, and create the box plot again, and you will see that this will give you more information. And I would like to illustrate the same thing with a different example. So, this is here the screenshot of the creation of the data frame of time and time 1 data. Now, I will take another example to show you the utility of box plots. Suppose the marks of 10 students in 2 different examinations are obtained, and we would like to compare the marks using the concept of box plots. So, the marks in the first examination, they are stored here inside a data vector named as marks 1, and the marks of those 10 students in second examination, they are stored here, and they are stored in a data vector marks 2. So, what I want here is the following. I want here a graphic like this one, where there are two box plots, one indicating the marks 1 and another box plot indicating the marks 2. So, in order to do so, first I try to create here a data frame using the command data.frame, and inside the arguments I try to give the data vector which I would like to combine, and this data, suppose I am trying to store as say data marks. Right. Okay. Now, this is the screenshot of this operation, and now I try to create the box plot of this data box plot data which has been obtained in the framework of a data frame, like this box plot of data box plot. Now, you can see here, now here you have a very nice and clear picture. By looking at these two values, these green color lines, you can easily compare that which data set or which of the group of student has got the lower marks or the minimum marks. Similarly, if you try to look at the red ink which I am highlighting here, by comparing this two, you can have an idea about the maximum marks obtained by the students. Similarly, if you try to look in the middle value, these are trying to give you the idea of the medians. So, by looking at these values, you can see here that the median in the marks 2 case is higher than the median marks in the case of marks 1. Similarly, in case if you try to compare this orange color part, this will give you the idea of the first quartile. And similarly, if you try to compare the third quartiles highlighted by this violet lines, you can compare it and you can see here that the third quartile Q3, that Q3 in the case of marks 2 has higher value than in the case of marks 1. And you can see here the range in the marks 1 and the range in the marks 2. So, you can see here that very clearly that the range of the marks 2 is higher than the range of the data in marks 1. And similarly, you can also compare the quartile deviation and interquartile ranges. So, you can see here this is how we can obtain it. Now, I will try to show you the construction of the box plots and the group box plots on the R software. Right. So, you can see here we already have the data on time. So, if I try to create here the box plot, it will look like box plot of say here time, and you can see here this comes out to be like this. Now, similarly, if you try to take another data set time 1, where we have increased the values of first two observation, then in this case this data set is here time 1, and you can see here that there are two extreme values, and if you try to create here the box plot of the same, this comes out to be here like this, which we had reproduced in the slides. Right. And in case if you try to combine here the data here, say here data, say here time is equal to data dot frame, and inside the bracket time separated by comma time 1 argument close, you will get here the combined data on time and time 1 in the data frame mode, and you can see here this is the data which I have obtained here. Now, I will simply try to make here the box plot of the same data set. So, you can see here if I try to create the box plot, this comes out to be here like this, which we had reproduced in our slides. And similarly, if I try to take here the data on marks, So, data on marks here is like this, and data on here marks here is like this. You can see here this is the data on marks 1 and marks 2, right. And I would like to combine this data into a data frame. So, I try to use here the data frame command, and you can see here this data has been combined, say here data frame like this, right. So, I would like to now create a box plot of the same thing. To box plot of the data marks, you can see here now this looks like this. So, you can compare it and can have some fruitful conclusions. Okay, so now I would stop here in this lecture, and I would also complete the discussion on the topics of different measures of variation. So, we have discussed different types of measures of variation, and every measure will give you a different information and a different numerical value. Your experience in dealing with the data sets and using these measures will give you more insight into the aspect that how to interpret, how to say whether the variability is low or variability is higher. This is always a relative term. But remember one thing, from the statistics point of view, in case if the data has very high variability, then most of the usual statistical tool will not really work well. They will give you some information, but that information may be misleading. So, it is very important to use the appropriate tool to bring the information out from the data regarding its inherent variability. Different samples taken by different people from the same population, they may have different variation. So, if you try to use different types of tools, ideally all the tools should give you the same information, but they will have different numerical values. So, I would request you that please try to look into the books, try to understand the concept of variation in the data, try to look the different drawbacks, different advantages of all these tools. All the tools cannot be applied in all the situations, and more importantly, how to compute them on the R software. This is what you have to learn. So, I would request you that you take some data sets and try to employ all the tools whatever you have done up to now, different measures of central tendency, different measures of variation, and try to see how these values are trying to provide you different pieces of information. So, you practice, and we will see you in the next lecture with a new topic. Till then, goodbye.